Yo, VIP. Let's kick it. Ice, ice, baby. Ice, ice, baby. All right, stop. Collaborate and listen. Ice is back with my brand.
This is the freezing of lauric acid lab. All of the materials that you'll need are right here. And then the procedure we're going to follow word for word. So the very first thing that we want to do is make sure that our beaker is getting up to temperature. We have our hot water bath. Our test tube is starting to get up to temperature with our lauric acid inside, just like so. It's liquidy, but it's not to the temperature that we want yet. We have our cold water bath, and now we want to prepare our table. So we open up the file from Lauric Pro, go to open, go to chemistry with Vernier, open up the freeze melt water. No, I don't want to do that. And I got this graph going on. Now, unfortunately, we're not using water, so we got to fix the title and fix the axes, because the y-axis is all the way down at -20 and down to +30. So we want it to go from 0 to 75. So quick fix that. So we're going to fix that by changing the title here to something sensible. We're changing it to something. Changing our axes to 75, and then down here to 0. Click on the bottom number, click 0. Now we're good to go. And so we take our test tube out of the hot water bath, as now it's to the temperature that we need. We're going to lower it down into our cold water bath and start dropping the temperature. And yeah, I'll hit collect. It's hard to do this with a camera in your hand and hitting collect all at the same time. So as we look in, we zoom in here, you can see that the collection is going. The temperature is just dropping like crazy. We're almost down. We started at almost 90 degrees, now we're down to 60 degrees in a matter of about 30 seconds. Well, 20 seconds. So it's going to continue dropping down, and we'll just watch. Just stir it up, stir it. Oh, zoom out a little bit. Oh, come on, why are you focusing? Ooh, focus, there it is. Stirring test tube. If we look closely at the lauric acid, we might notice that rather than being a liquid, we're starting to see solid coming on, starting to form on the sides. So we're starting to see it transition from liquid to solid, just like so, in our cold water. And we look back at our graph, you can see now starting to level off. You see it's totally starting to level off. And if we look at our data, see how it's just sitting there at 45.3, 45.3, and 45.2. It's just slowly dropping temperature now. It's not such a drastic change as before. And after several minutes have gone by, now that you look at the graph, we see a definite drop and then leveling off, and now the graph is starting to drop off again. You can see right here, we're at the, what minutes? What was that, 5, 6, 7, 8 minute mark? Around the 8 minute mark almost. So we're definitely seeing a transition from one thing to another. You guys, your job is to actually interpret what the graph's going on here. You're going to see a blank graph. You're going to have this copy of this graph. You're going to have to label it like the instructions say. You're not going to be using the text annotation like the program has, but you're going to have to actually do the labeling yourself on your own graph. So now that the data collection's all finished, there's our graph. Let me close this out because it doesn't need to be there yet. So I have an entire graph here. We're going to now do the stats button just to show you the mean average of the freezing point temperature. Just to show you, this is the lauric acid. Now it's in the solid form. Before we had liquid, and now we have solid. All right, freezing, wonderful. So rather than just giving it to you, I want you to actually determine which one is the freezing point of this graph. So what we've discussed in class, or what you've discussed in your own classes, your other chemistry class, I want you to just decide. I have a text box here that's going to tell me my mean average, which I'll zoom into, but it's basically analyzing this part of the graph as the freezing point. Or is the freezing point between here, between these two brackets here in the graph? Or do you think it's in that part of the graph right there? So looking at the stats boxes, if you think it's the very beginning of the graph, you can see the mean temperature of the freezing point would be 56.24 degrees Celsius. If you think it's the middle section that's down here, you would say the mean is 41.94 degrees Celsius. Or if you think the freezing temperature, the freezing point temperature is down here in this section right here, then you'd say the mean is 32.39 degrees Celsius. So it's up to you to decide which one is actually the correct mean freezing point temperature. Last thing, you have a blank graph. I'm giving you this graph. I'm printing it out, I'm sending it to you, or you got it from me. You just need to label each of the graphs, or label each section of the graph where you have some sort of phase. If you have a certain state to label or a phase change to label, I want you to label each section of the graph, kind of like what we did in class the other day. And once you've done that, you answer your questions on the back side of the graph itself that you have, and you're all said and done.
I'll stop the world and melt with you. You've seen the difference and it's getting better all the time. There's nothing you and I won't do. I'll stop the